As a static equipment engineer, you can able to design a pressure vessel without shell, without distance, but without nozzles, no. Almost all the pressure vessels have nozzles. Without nozzle connection, it can't be a pressure vessel. The nozzles are very important for a pressure vessels. Today we are going to discuss about the different types of nozzles, functions of the nozzles, and where are the nozzle located, and industrial applications of the nozzles. In this image you can able to see almost I have tried to implement all the nozzles. These are the nozzles connected with the flange, these are the nozzles connected with the TC end, these are the blind flanges. Here you can able to see the nozzles are connected with the internal thread. Here are the manway connections you can able to see. Here you can able to see the view glass nozzles, and here you can able to see the plug of the nozzle connections, and we will see everything in detail in further slides. First thing we need to answer is, why so many nozzles? There are many nozzles, right? You can able to see there are different kinds of nozzles are assembled in this pressure vessel. Why? Pressure vessels are not only the storage tanks, it is a active processing unit. There must be a continuous process inside the pressure vessel. If the process is very low, we can able to see very less number of nozzles. If the process is relatively high, we can able to see there are many nozzles available on the pressure vessel. And we have constant exchange. Fluids continuously enter, leave, vent and drain. And there will be some unique purpose also. Every single nozzle is designed specifically for the distinct task. And in coming slides you can able to see there are different kinds of nozzles. All the nozzles have a specifically unique requirement. This one is an important statement. A nozzle is the vessel communication point with the rest of the plant. All the process fluids from different kinds of pressure vessels or any other tanks or any other heat exchangers are communicated via nozzles. That's why we need nozzles in each and every pressure vessels, heat exchangers, storage tanks, whatever you design as a static equipment, you need to have a nozzle. What exactly is a nozzle? We are talking about the nozzle. First we have to understand what is exact nozzle is, then we can get into the detail. What is a nozzle? An opening welded to the pressure boundary providing a connection point. It is a opening welded to a pressure boundary. Pressure boundary means it can be a shell, it can be a dish end, it can be the end closures, or even sometimes the nozzles are directly connected to the nozzles also. Sometimes you can able to see the nozzles are connected on this surface. That must be very small nozzles. Yeah, even here this is also a pressure boundary. This is the nozzle neck. This is also a pressure boundary. Whatever the pressure is directly acting on the surface, that we will call as a pressure boundary. It is a pipe section which is welded to the shell or dish ends, but most of the places it might be a pipe, but sometimes it might be a forging also. Because if it is a huge pressure for the HP systems, for the high pressure systems, mostly for the steam drums, if it is a high pressure system, we can't able to satisfy with the pipe thickness, normal pipe thickness we can't able to satisfy. So during that times what we will do is we will go for a forging. Reinforcement pad. Here you can able to see this is the reinforcement pad. The reinforcement pad is an extra plate to restore the strength. We will see everything in detail in further slides. And finally flange, the bolted connection to the external piping. Here you can able to see the flange. Here our process pipe will be connected, and which is connected to the another flange. Those both flanges are connected using bolts. Sometimes it can be a direct butt welding also, but most of the times it might flange connection. Remember this picture. Here you can able to see this is the shell. Here we are making a opening in the pressure boundary for the communication of fluids. This is the reinforcement pad which is directly welded to the shell. You can able to see here. This is the neck. Usually it is made up of pipe, and here you can able to see the flange. Actually there are different types of flange which are available. Mostly the weld necks are used for the process connections, high end process connections, that means high pressure process connections. But we can also use the slip on flanges. We can also use any other long neck flange or any threaded flange, or here we can also able to use the threaded connections also. Without flanges we can able to directly use the threaded connections also, but most of the threaded connection will be for the very small nozzles like 1-inch nozzles, half-inch nozzles. Mostly those are used for the instrumentation connections. Classification of the nozzle. In the pressure vessel, the nozzles are classified into process, utility, safety, instrument, maintenance and special purpose. We will see everything in detail in coming slides. First, process nozzle. A pressure vessel must have a inlet and outlet connections. In the inlet nozzle, where the main process fluid enters, outlet nozzle it is vice versa, where the process fluid exists. Recirculation nozzles, mostly you can able to see these recirculation nozzles in the heat exchangers. Overflow nozzle, that prevents the liquid level from exceeding the maximum limit. Most of the overflow nozzles you can able to see in the low pressure vessels. Mostly in high pressure vessels overflows are not mostly common. In each and every one house we have a overhead tank. The overhead tank normally has a inlet nozzle, outlet nozzle, Circulation nozzle, it is most not a common one in the overhead tanks. We have overflow nozzles also. All the three nozzles we have in our overhead tanks also. Utility and maintenance nozzles. The first one is vent nozzles. The vent nozzles are mostly available in the top of the pressure vessel. It removes a trapped air during the filling and hydro testing. Mostly during hydro testing, we need to fill the water in a very fast manner, so that we can able to avoid some maneuvers. What the pressure vessel manufacturers try to do is try to fill the water very fast. During that time, if we have a vent, we can open the vent and allow the air to escape outside, and we can able to fill the water easily. For that purpose, we use the vent nozzles, and also during the filling, during the process filling also they use the vent nozzles. Drain nozzles, as the name itself it suggests, drain nozzle. Drain nozzles empties the pressure vessel for the maintenance, and also during the process time also. Steam out nozzles, it injects a steam to clean the toxic chemicals before the opening. Mostly in the pharma, in the chemical, and also in any other petrochemical industry also, if we need to enter inside the pressure vessel for any maintenance, we need to steam out the vessel. Why we are doing steam out? Steam helps to escape all the air or any other toxic element inside the vessel or inside the tank to exit from the pressure vessel. So we have steam out nozzles and sampling nozzles. Sampling nozzles you can commonly able to see in the pharma vessels. The nozzles are available on the shell side. We can able to extract a small amount of fluid for any lab testing or any other testing purposes. Safety nozzles, we have discussed in the previous video also. Actually, safety nozzles, we have pressure relief valve, we have rupture disc, we have vacuum breaker, and also emergency vent. As I told, pressure relief valve we have already discussed in my previous video. If you doesn't watch my previous video, please watch that video. Actually, pressure relief valve is normally used to relieve the extreme overpressure in the pressure vessel. And rupture disc. Rupture disc is a sacrificial membrane that bursts instantly to protect against sudden pressure spikes. If the pressure vessel fails, then the rupture disc will do this work. Actually, it will break a small membrane and it will release the pressure. It will cause a permanent damage in the rupture disc, but it will save the whole pressure. So we use the rupture disc. Vacuum breaker, it is almost similar to the pressure vessel, but it is vice versa. Pressure vessel relieve the pressure. When the vessel seems overpressured, the pressure relief valve will open the pressure and relieve the pressure. But in the vacuum breaker, when the vessel experiences more vacuum, if we need very partial vacuum or a small amount of vacuum, it will let the air in and maintain the vacuum pressure. Emergency vent, actually emergency vent is a large hatch designed to blow open in the case of an external fire expanding the gases. This type of emergency vent you can able to see in the paint industries, mostly paint industry, and also if there is any solvent included in the particular plant, you can able to see these kind of emergency vents. Instrumentation nozzle, we are talking about the pressure vessel, right? Then we need to measure the pressure. For that purpose, we use the pressure gauges and also temperature gauges. We need to measure the temperature and also level gauges. The pressure gauge opening are usually small. It will be around 1 inches to 2 inches. Here you can able to see the pressure gauge. Normally the pressure gauge you can able to see in the top of the vessel. Level gauges are usually two nozzles. Here you can able to see this is the one nozzle and this is the one nozzles, and we will make a loop connection between these two nozzles, and in the center portion it will be a glass, so you can able to see the fluid level outside the tank without looking inside the tank. Special purpose nozzle and access nozzle. Access nozzles you already know, we have manway and we have handholds. This is the handhole and this is the manway. Manway is usually a larger size nozzle which human can able to enter inside and do the maintenance work. And handhole, comparing to the manual, handhole is smaller one. Only we can able to insert our hand for any cleaning purpose or inserting any probes. Agitator nozzle, actually it is a heavy duty nozzle, mostly located on the top of the pressure vessel. Sometimes it will be available on the side of the pressure vessel also. In the side bottom it will be available, but it is not mostly common in the pressure vessels. You can able to see those kind of status in the paper manufacturing plant. Paper has higher density, so it will settle in the bottom of the pressure vessel, and the vessel will be very huge in size. If we are operating the agitator from the top, means we require a huge amount of power to operate the agitator, and also the mixing is not that efficient. For that purpose they will provide agitators over here. It is not most common in the pressure vessel, but it is most common in the storage tanks. And comparing to the other nozzle, here you can able to see the nozzles are supported with many stiffness, that is to support the weight of the agitator, and also it is required to support the vibration which is generated by the gearbox and motor. Nozzle orientation and placing, mostly you can able to see the nozzle will be placed on the top of the pressure vessel, side of the pressure vessel, bottom of the pressure vessel, and also tangentially most of the times you can also able to see the nozzles located on this place also. When a nozzle is located on this place, it is called as a hillside nozzle. It is not a radial nozzle. Nozzle won't connect like this. Nozzle will connect like this direct straight line. Those kind of nozzles will be called as hillside nozzles, and the nozzle connected like these are called as radial nozzle. Why reinforcement is essential? In the initial video we saw the reinforcement pad, right? This is the reinforcement pad. Here you can able to see. While we do this opening of this nozzle, we will lost some material, right? We will lost some material in the shell or in the dish. We will remove this material. This is the material which we are removed. So we need to compensate that material. We need to compensate that particular removed material near the removed place. That we will call it as reinforcement. Why we need to compensate? We need to compensate because of stress concentrations. In the pressure vessel, most of the stress concentration will be on the edge of the pressure vessel. Here you can able to see. And also we need to compensate the material whichever it is removed. Here you can able to see the real vessel mapping. In the industries you can able to see these are the connections which we are going to give in a common pressure vessel. In the top you can able to see vent and pressure relief valves. In the sides you can able to see feed inlet. Also in the side you can able to see manway. In the bottom you can able to see the liquid outlet and the drain. In the bottom and in the top you can able to see the level gauges. It is connected like this. In the side you can able to see thermo well. Mostly the thermo will available in this position. Sometimes the thermo will also will be available in this position also. The typical industrial arrangement. I have taken a 3 important pressure vessels and we will discuss what are the nozzle connection we can able to see in these pressure vessels. The first one is steam drum. I have wrongly put the image. Actually the steam drum is this one. In the steam drum, here you can able to see a feed water inlet and the water exit outside by the downcomers, which is directly connected to the evaporators, and from the evaporators there will be nozzles connected to the drum, that is called as risers. And from the risers the steam exit outside via the steam outlet. These are the typical nozzles in the steam drum. In the separators we can able to see the tangential inlet, and in reactors you can able to see a heavy agitator in the top, and there will be more nozzles will be connected on the side, top, bottom, everywhere, because it requires a huge process. There will be a huge process taking inside the agitator. That's why there will be more than 2 to 3 inlets, and there will be 1 or 2 outlets will be there, and there will be also drain, vent, level gauges, instrument nozzles, everything will be available on the chemical reactors. Design consideration. While we designing a nozzle, we need to consider the piping loads. The connected pipes expand with heat and push and pull the nozzle. We have to consider the moments and torques. The nozzle neck acts as a lever arm stressing the shell, and we have to consider the accessibility. For the piping loads and moment and torque, we can able to use a WRC 105 and 297 to calculate is there any stresses available on the pressure vessel. Did we need to provide any other extra reinforcement pad or any extra nozzle thickness or any extra shell thickness? For those kind of things we can able to calculate using WRC 107 297 also. Okay, we have came to the end of the video. In this video you can able to get the takeaway as every nozzle has a specific process, safety or utility function. Location is detected entirely by fluid dynamics and accessibility. Cutting holes weaken the shell. Reinforcement is mandatory. A nozzle must withstand several mechanical loads from connecting pipes. In this video, I think you got a good knowledge about the nozzles and its connections. We will see in the next video. Until then, bye bye.